Alright, hey guys, so this time we're going to be talking about factoring polynomials. So if you don't know what all of this is about and why I'm making videos, I'm making math videos based on your request. So if you ever need help with a math topic, just tell me and I'll make a video about it. So let's get into factoring polynomials. So first of all, why do we do that? Well, think back to your algebra 2 days when you're on quadratics. Let's say x squared plus 3x plus 2 equals 0, and you need the solutions for this quadratic. Well, it's kind of just hard to guess a solution from this unfactored form, but once we factor it, it gets a lot easier. So I'm skipping all the steps for factorization here to save time, but I'm just showing you the end goal of factorization here. So we know the factors, and we know that the right-hand side is 0. So if these two factors multiply to 0, one of them must be equal to 0 itself. So then we can easily see that the solutions are x equals -1 and x equals -2. And you kind of just can't tell that from the original equation. So let's look at an example of factorization. So let's say we have the polynomial 24x cubed minus 6x squared plus 28x minus 7. Okay, so the first thing you want to do is you want to group the terms into two. So I'm bundling up the 24x cubed and 6x squared, hoping to pull a common factor out of all of them. And I'm also bundling up the 28x minus 7, also hoping to find a common factor between them. Okay, so now we see what multiplies into both 24x cubed and -6x squared. Now, first of all, let's look at the degrees. So the lower degree is a 2 here. So we know that x squared goes into both terms, definitely. And if we look at the common factors of 24 and 6, we ignore the sign for now, you can see that the biggest common factor is actually just 6. So we can pull out a 6x squared from this entire expression here, and what do we have left? So 24x cubed divided by 6x squared, 24 divided by 6 is 4, x cubed divided by x squared is x, and -6x squared divided by 6x squared is just -1. And let's do the same thing on this side. So we have a constant term here, no variable, so there's no powers of x that go into both. However, we can find that the greatest common factor of 28 and -7, the biggest number that goes into both, is just 7. So 28x over 7, we're left with 4x, and -7 over 7, we're just left with -1 yet again. So good news, we actually got the exact same factor from both groupings. So that's called a common factor here. So both terms share a 4x minus 1. Now, what are the terms exactly? Well, we know there's 6x squared copies of 4x minus 1. There's also an extra 7 copies of 4x minus 1. So there is our factorization. Now to check, we can FOIL. So 4x times 6x squared, 24x cubed, -1 times 6x squared is -6x squared. I did foiling out of order, but the foiling, you're just adding and subtracting, so it doesn't matter. Now 4x times 7 is 28x, And finally, negative 1 times positive 7 is negative 7. So now we check that our factorization is correct. So now this factoring problem is done, and this is the factored form of our original expression. Now, while the factoring process is kind of straightforward once you know what you're doing, there's a couple of very common mistakes. So I want to make sure none of you fall into this mistake. So let's take the expression x cubed minus 2x squared plus x minus 2. So again, we will group the terms together. Group the first two terms together, x cubed minus 2x squared. And then let's group the x minus 2 together. So first of all, sometimes you might forget that you can pull out just pure powers of x. So right now there's nothing that goes into 1 and 2, but there is something that goes into both x cubed and x squared, and that is just x squared. So, and then you complete the factorization here. Now, we can see nothing goes into both 1 and 2, and there's no power of x that goes into both either. So we're just left with x minus 2. So you might think that our solution is just, our factorization is just x squared times x minus 2. Now, you'd be wrong, however, because let's check it out. So if we expand this, we get x cubed minus 2x squared. So where do these terms go? Well, actually, when I said nothing goes into x minus 2, that's just straight up wrong. So what actually goes into x minus 2 is just 1. So this is a much more common mistake. If you don't see anything that goes into both terms that you could factor out, you always factor out a 1. That's still very important. And now our factorization becomes x minus 2, and then times how many copies of x minus 2 do we have? We have x squared of them, and we have 1 of them. And let's do the foiling now. FOIL, F-O-I-L, x cubed plus x minus 2 x squared minus 2. That doesn't look exactly the same, but it's just rearranged terms, so it doesn't matter. So you don't want to make the mistake of not seeing what you can factor out. Either you could factor out a power of x, either you could factor out 1. They're all very important to keep in mind. Now let's look at another example of a common mistake. So let's go with 2x squared minus 4x. Hang on. Okay. Now let's change it up. 2x squared minus 6x. Or let's do plus 6x. Minus 3x minus 9. And so now you notice it's not a cubic polynomial anymore, it's a quadratic. You can combine these like terms, but they are broken up in a very specific way to help with factoring. So let's do the same thing again. Let's combine this into two binomials, just two polynomials with two terms each. A lot of 2's. And then minus 3x minus 9. Now this is the other big error. So because the negative actually distributes to both terms. So if you just wrote it like this, you would end up getting negative 3x plus 9, which is not the same as what you had before. So there are two ways of fixing it. One way is you could change it to adding a negative number, adding negative 3x, and then minus 9. That is correct. Or you can immediately pull out the negative. But remember, the negative goes to both terms, so you actually have to reverse every sign after that. So minus 3x plus 9. However, the negative and positive here, that becomes the negative as before. So now let's do the factorization again. What goes into 2x squared and 6x at the same time? That would be 2x. Don't forget the x here. X plus 3, and then minus, and then what goes into both 3x and 9? That would be 3. And then you're left with x plus 3 as before. And so now x plus 3 is our common factor. And now how many copies do we have of x plus 3? Well, we have 2x there, and we have negative 3 copies here. Watch out very carefully for the negatives. You should always FOIL it out to check your work if you're unsure. I won't FOIL this out for time, but just know you always want to look out for negatives. And just one last note, this actually isn't that new. So let's say we have something like 3x squared minus 7x plus 2. So you might notice we don't have 4 terms here. We could split evenly into 2 and 2. Now, if you haven't learned factoring higher order polynomials yet, you might be able to brute force this out with like slip and slide or something. But now, on like a test, you might get it broken up nicely like this. Minus 6x minus x plus 2. Okay, and let's practice because we'll see a bunch of the same mistakes that we did before. So this is a great final example to end on. So let's bundle these terms up, but if we're going to be watchful of the negative, we're actually going to have to reverse the sign if we bundle up the negative there. Okay, so what goes into 3x squared and negative 6x? That'd be 3x. And you have x minus 2 here, minus, well, again, it doesn't seem like anything goes into both x minus 2, but 1 goes into both of them. So let's pull out a 1. And pulling out a 1 doesn't change the factor, but it's very important to remember that 1. Otherwise, you'll end up getting the wrong answer and missing an entire factor. So now x minus 2 is our common factor. And how many copies of x minus 2 do we have? We have 3x copies from the left, and we have negative 1 copies from the right. And there we go. That is our factorization. So hopefully you guys understand better how to factor now and how to avoid common mistakes while doing that. Again, if you have video requests, just tell me, and I'll see you guys soon.